Grade 12, we're on our 9th day of exponential functions and we're looking at solving with logs. So notice we're back to our primary focus in this course of solving things. And you did 4 different ways already of looking at solving exponential. So our job now is to look towards solving exponential equations by using logs. So we just have to get used to the rules of logs in order to do that. So our first example here says if log base 2 of 16 equals 4, because, kind of off to the side, we'll say, yeah, that's true, because 2 to the 4 is 16, so that's true. And log base 2 of 4 is 2, and that's true because 2 to the 2 is 4. I happen to know by looking at the 4 and the 2 that log base 2 of 16 plus log base 2 of 4 is equal to 6, simply because 4 plus 2 is equal to 6. It also happens to be true that log base 2 of 64 is 6. All right, keeping that in mind. Log base 3 of 81 is 4, because 3 to the 4 is 81. So that's true. Log base 3 of 9 is 2, because 3 squared is 9. Let's add those ones as well. Log base 3 of 81 and log base 3 of 9, so same bases. And I get 4 plus 2 is 6. So that one plus that one equals 6. It happens to be true that log base 3 of 729 is 6. What's the relationship between 81 and 9 that can give me this same answer when we're looking at log base 3? One last one. Log base 5 of 125 is, okay, 5 to the what is 125? Well, 5 squared is 25. 5 cubed is, what do you know, 125. Log base 5 of 5, 5 to the what is 5? Oh, it's 1. Okay, so 3 plus 1 is 4. So log base 5 of 125 and log base 5 of 5 is 4. Log base 5 of what is also 4? 5 to the 4 is 625. The relationship is 125 times 5 is 625. So if I have a product, I can write it as an addition. Here we are in general terms. Log base A of the number B plus log base A of the number C. It's the very same thing as log base A of the B times C. That's our first rule. Second rule. Log base 5 of 125. Well, we already did that. Log base 5 of 125 is 3. And log base 5 of 5 is 1. And if we were to do subtraction, 3 take away 1 is 2. So if I were to subtract those two, what log base 5 of what number is equal to 2? Because I know where I'm going with this thing. 5 squared is 25. Okay, second one. Log base 3 of 243 is 5. You're not expected to know that. I happen to know that 3 to the 5 is 243. Log base 3 of 27 is 3. I know that 3 cubed is 27. Okay, let's subtract them. Log base 3 of 243, subtract log base 3 of 27. I know their values. 5 take away 3 is 2. What else is equal to 2 for log base 3? Well, 3 squared is 9. What is the relationship between 243, 27, and 9? 243 divided by 27 is 9. So here's our second rule. If you subtract logs, it's got to have the same base though. Log base A of some number subtract log base A of another number is the same as log base A, little a, of the first number divided by the second number. So you can rewrite a division as subtraction with logs. We have one more rule. If you do log base 3 of 9, you get 2, because you know that 3 squared is 9. I am just replacing the 9 with a different expression. So those two are the same, so they have to be equal to each other. Log base 3 of 3 squared is 2. Well, that's just silly. Log base 2 of 32 is 5, because I happen to know that 2 to the 5 is 32. And I've just rewritten that 32 as 2 to the 5 is equal to 5. Note that log base 2 of the number 2 is a 1. So if I have 5 times log base 2 of 2, I get the number 5. So these two seem to be the same thing. Let's look at the one above it. What is log base 3 of 3? Also a 1. And 2 times log base 3 of 3 is the number 2. So if I were to bring that exponent down in front of the log, I would have an equivalent expression. So looking at the one here, log base 2 of 2 to the 5 is the same as 5 times log base 2 of 2. It happens to be 5. So my rule is, if I am taking a log of a power, b to the c, that would be the same thing as bringing the exponent to the front, log base a of b. That one is so useful as we solve. Okay, now that you have your 3 rules in front of you, let's do a few. Evaluate. Log base 6 of 2 plus log base 6 of 108. Neither one of those is very pretty. Log base 6 of 2, not so nice. Log base 6 of 108. So I'm going to replace that by an equivalent expression. Adding logs could be rewritten as a multiplication. So log base 6 of 2 times 108 is the same as adding those two logs. So log base 6 of 216, which happens to be 3. Second one, that's also adding. Log base 10 of 5 plus log base 10 of 20. I can use my rules because I have the same base for both. That would be the same as log base 10. Adding logs is the same as multiplying of 5 times 20, which is log base 10 of 100. Log base 10 of 100 is 2, because 10 squared is 100. Subtraction. Log base 3 of 108. Take away log base 3 of 4. When we subtract, that's the same as dividing. So it would be the same as log base 3 of 108 over 4, which is log base 3 of 27. Log base 3 of 27 is 3, because 3 cubed is 27. Other subtraction question. If you have a subtraction, that would be the same as division of 160 over 10 is 16. Log base 2 of 16 is 4. Log base 4 of 64 to the 9. Okay, that's ugly. And if I have a power, I can rewrite that as bring down the 9, log base 4 of 64, which is 9 times log base 4 of 4 is 3. 9 times 3 is 27. Log base 5 of 25 to the 16. So with my rules of logs, I can bring down the 16 times log base 5 of 25. 16 times log base 5 of 25 is 2. Since 5 squared is 25, I get 32. Our whole purpose for looking at these rules of logs is to solve exponential equations using logarithms, which is what I would automatically gravitate to, and you not so much yet. For this solve, 5 to the 2x plus 2 equals 9. I am going to take the log of both sides. So log of 5 to the 2x plus 2 equals log 9. Now it is assumed, because I'm going to use a calculator in a bit, that I'm using log base 10. It doesn't matter what base you use for this at this point. All right. My rule on the left side, if you have an exponent, you can bring the exponent down to x plus 2 times log base 10 of 5 equals log base 10 of 9. I don't have to write those base 10s. It's understood when you're going to use a calculator. I want to get x by itself eventually, so I am going to divide both sides by log of 5. I'm going to continue to solve that. Log base 9 divided by log 5, sorry, base 10 of 9. I get on the calculator 1.3652. I know how to solve from there. I would subtract 2 from both sides. Negative 0.6348 divided by 2, negative 0.3174. I have an answer for x. Let's solve this using logs. I have an exponential equation. I'm going to take the log, base 10, because that's what my calculator has, of 4 to the 3 minus 2x equals log of 5. I'm going to use my rule of logs on the left side that says I can bring the exponent down, 3 minus 2x times log 4 equals log 5. I'm going to divide both sides by log 4. Now I'm just dealing with numbers because my calculator can tell me what log of 5 divided by log of 4 is, and it is 1.16. And then I continue to solve like I always have. I'm going to subtract 3 from both sides, minus 1.84. Divide both sides by negative 2, decimal 92, approximately. The equation P equals 100 times 0.87n models the percent of caffeine in your body n hours after consumption. What is the percent after 3 hours? So you keep 87% of the caffeine you drink in your body every hour, and you lose the remainder, 13%, every hour. We want to know what percent you're left with after 3. So we're just going to solve this one by substituting 3 in for n. So that's easy. Just type that in our calculator. We started with 100%, 87%ing it every hour to the power of 3. Here we go. 65.8685. So in 3 hours, you are left with about 66% of what you started with. When is half the caffeine left? So I want to know, when do I have 50% of what I started with? So 50 is equal to 100.87 to the x And when is that? If I want to solve for an exponent, I would take the log of both sides. I am going to tidy a little bit for a second though. I am going to divide both sides by 100. 0.5 equals 0.87 to the x. I have an exponential equation. I am going to take the log of both sides. Log of 0.5 equals log of 0.87 to the x. I know for my rules of logs on the right side, I can bring the exponent down. X times log of 0.87. Well, to get x by itself, I'm just going to divide. Log of 0.5 divided by log of 0.87. My x value is approximately 4.98. So after about 5 hours, I will have half of the caffeine left that I started with. If I have a large coffee, which is 165 milligrams of caffeine, I looked it up, at 7 a.m. when I'm getting ready for school, when will I have optimum caffeine level for teaching? I made that number up though, approximately 60 milligrams. So my equation was, how much caffeine do I have? Start with 100. Okay. This time I am talking about milligrams. I'm going to keep, I have the same ratio of growth, but I'm going to be talking about milligrams now instead of percent. So if I start with 165, and this is from 7 a.m., I want to know when, after 7 a.m., I am going to have 60 milligrams. So my equation would look like, when does 60 equal 165 times 0.87 to the x? So let's divide both sides by 165. So I will have 0.36 and so on. If I want to solve for an exponent, using logs is always so beautifully accurate. I would take the log of both sides. Our rules of logs state, then I can bring down the exponent, x times log base 87, 0.87, sorry. And to get x by itself, I'm going to divide both sides by log 0.87. X is approximately log 364 divided by log 0.87, 7.25, which is 7.25 hours after 7 a.m., which is about 2:25. So I am good to go just as you're leaving. I have a couple sheets for you to work on for solving these guys.